Hey there guys, here's another video showing how to connect Arduinos via Wi-Fi to the Blynk app on your phone. This video is a little different from my previous videos on the topic because I'm using different hardware. What I have here is an Arduino Due connected to an ESP-WROOM-02U, which is connected to this external antenna. This circuit connects to my home Wi-Fi. My phone here is also connected to my Wi-Fi. Just to demonstrate the communication, I will use the Blynk app to control this LED. And I can monitor the position of this potentiometer and I can see the millis output from the Arduino. So indeed, this hardware and configuration looks similar to my first video where I showed how to connect an Arduino Mega 2560 and an ESP-01 and Blynk. And in my second video, I showed how to connect an Arduino Uno and ESP-01 and Blynk. I guess I should mention that this tutorial is primarily focused on getting the Wi-Fi communications working, which I have to say is pretty difficult if you've never done it before. The LED and potentiometer are very simple circuits, and they are only used here to demonstrate the setup and use of the Blynk app. I assume you have something much more interesting and useful than an LED and a potentiometer for your project. So why is this video different from my previous videos? First, as I mentioned, I'm using the Due, which has some cool features. Also, I'm using the ESP-WROOM-02U Wi-Fi module, which, obviously, is a bit different from the ESP-01. In a minute, I'll explain why I chose these particular devices. Also in this video, I'm going to show how to flash the Wi-Fi module using the Arduino instead of a separate USB to TTL converter, as I did in my previous videos. There is one other big difference. In my previous videos, I used the cloud server provided by Blynk to handle the data exchange between my phone and the circuit. That cloud server is convenient and easy to use as long as you have good internet access and you are not restricted by firewalls. In this video, I will first set up the circuit using the cloud server. But then, I will also show how to set up a local server on your network so you do not have to rely on the cloud to exchange data. Setting up a local server is a bit complicated compared to using the cloud, so later I will explain a few reasons why you might want or not want to use a local server. So why am I using the Due for this project? First, the Due is a 3.3 volt device. Basically, all of its inputs and outputs operate in the range from 0 to 3.3 volts. This differs from the Mega and the Uno, for example, which are 5 volt devices. Because the Due is a 3.3 volt device, we can connect it directly to the 3.3 volt Wi-Fi module without any level shifting. This makes wiring up the project a little easier. But beware, do not use the circuits in this video and assume that you can use a Mega or Uno in place of the Due. You can't do that without including level shifting components. I won't cover level shifting in this video, but I did show how to do it in my previous videos with the Mega and Uno. In those videos, level shifting was done with an adapter like this or with a voltage divider. The Due also has a 3.3 volt output that is capable of delivering 800 milliamps. This is sufficient to run ESP Wi-Fi modules, which can draw up to 430 milliamps. You cannot reliably run an ESP Wi-Fi module from the Mega or Uno's 3.3 volt supply, because those boards only provide about 50 milliamps. For the Mega and Uno, you have to incorporate either an adapter like this or an external 3.3 volt supply like this. So again, the Due's 3.3 volt supply can provide up to 800 milliamps, so we can use it to power the VCC input of the Wi-Fi module in this project. Another advantage of the Due is it has more memory, about twice as much as the Mega. If you think you are going to be doing a lot of stuff with your Arduino, maybe lots of inputs and outputs with the display and so on and so forth, you might be glad you have a lot of memory available to handle a large sketch. Also, the Due has a really fast microcontroller running at 84 MHz. The Mega runs at 16 MHz. The The Due also has a real digital to analog converter. Actually, it has 2 DACs. I won't use them in this video, but I have other projects where the use of a DAC will be helpful. I don't think any other Arduinos have a built-in DAC. The microcontroller on the Due has a CAN bus interface too. I hope to make use of that in the future. Lastly, I'm using the Due because it is new to me, and I like trying out new gadgets. In my previous videos, I used the ESP01 Wi-Fi module. So why am I using the ESP-WROOM-02U? One reason is that it is certified to be compliant with FCC and CE regulations. This might not be important to the average hobbyist, but if you are developing a commercial project, it is something to consider. The second reason I like the ESP-WROOM-02U is because it includes a connector for an external antenna. I think with an external antenna I can extend the range of my project. I don't have any hard numbers to back it up, but it seems logical. A bigger antenna will give you a bigger range, right? If you prefer to have a Wi-Fi module with an onboard antenna, you can get the ESP-WROOM-02D or any one of a dozen other Wi-Fi modules that are available on the market. This video only focuses on the ESP-WROOM-02 module, but it is very similar to many other ESP modules out there, so you can probably extrapolate and adjust the wiring to make any ESP module work as shown in this project. You can get all of the hardware for this project from online stores like Amazon or from brick-and-mortar electronics stores. Hey, support your locally owned businesses if at all possible. So this is the hardware that I used for this project. This is the Arduino Due. It can be easily found on many websites. If you want to duplicate the project exactly as shown in this video, you will need an ESP-WROOM-02U or ESP-WROOM-02D. There are a few online sources for this device, including Amazon and ElectroDragon. Just note that shipping from ElectroDragon can take a long time, like 2 or 3 weeks. In this video, I use a breakout board for the ESP module. This one is designed specifically for the ESP-WROOM-02. I don't think it is suitable for any other Wi-Fi module. This board is available on Amazon in the US. I don't know if it is easy or hard to get one in other countries. In this video, I use an external antenna. You need to look for something in the 2.4 GHz range with this U.FL IPEX style connection. This is a pretty good example of what you should look for. As you can see, you will need an LED, a 10K potentiometer, a breadboard, and wire. You'll need at least 6 10K ohm resistors for the Wi-Fi module, and you should have a low value resistor, maybe 100 ohms or so, to limit the current to the LED. If you need a lot of these small items, you might want to buy a kit like this. And of course you will need a USB cable to program the Wi-Fi module and the Arduino Due. If you are going to solder a board together like this, then you will need some basic soldering tools and a voltmeter. These don't have to be super high-end. The soldering iron and voltmeter I use in this video were very cheap, but I have to admit I was tempted to buy some better equipment to make the work a little easier. Do what is right for your situation. So in the next part of this video, I'm going to show how I soldered the Wi-Fi module to the breakout board. You should skip ahead about 2 minutes if you don't intend to solder together such an assembly, or if you're insulted when other people try to show you how to solder, or if you intend to mock me for my awful soldering technique. Here I am using the ohm meter setting on my meter to check for shorts that might be caused by sloppy solder joints. I also use the meter to confirm continuity from the header pins to the corresponding contacts on the Wi-Fi module. The next thing to be done is to program the Wi-Fi module with the correct version of the AT commands firmware. The Blynk website recommends using this version. We can download that firmware from this website. The link for this website will be in the description of this video. After you download and extract the folder, you will see there are two versions of the .bin file. One is for 8 megabit ESP devices like the ESP-WROOM. The other file is for 32 megabit devices like the ESP12. On Espressiv's website, I found a listing of some of its ESP modules, and it shows the ESP-WROOM-02U has 2 megabytes, which is 16 megabits, of flash. So I'm guessing that the 32 megabit version of the .bin file will not work on the ESP-WROOM-02U. I have used the 8 megabit version and it works just fine. And that is what you will see in this video. We will flash the 8 megabit version of the .bin file onto the ESP-WROOM-02U. If you are using a different ESP module and you don't know the size of the flash, then use the 8 megabit version. Most likely it will load up and work just fine. I recommend this flasher. It has always worked well for me. A link to the website where I got it is in the description of this video, or you can get this flasher from my Google Drive. So anyway, make sure you have this flasher and the correct .bin file. And next, we will wire up a circuit that will let us flash the Wi-Fi module using the Arduino Due as our interface. Now, I want to emphasize again that the circuit that we will use for flashing the Wi-Fi module will only work with an Arduino Due, because the Due has a 3.3 volt supply that can provide 800 milliamps, and the signal levels on the Due are 0 to 3.3 volts, which matches the signal levels of the Wi-Fi module. You should not use this circuit with a Mega or Uno, because the Mega and Uno are 5 volt devices and their 3.3 volt supply can only provide 50 milliamps. If you want to use a Mega or Uno to flash an ESP module, you should use an external 3.3 volt supply to power the ESP module, and you should use a voltage divider or level shifter on the RX line. My previous video where I use an Uno and ESP-01 should help you understand the use of a voltage divider and the external power supply. Another option for flashing ESP modules is to use a USB to TTL converter. Both of my previous videos showed how to use a USB to TTL converter for flashing. But let's get back to the project with the Due. This is how to set up an Arduino Due to flash the Wi-Fi module. If you know a little about ESP modules, you can use virtually the same circuit to flash almost any ESP module. But as you can see here, I'm going to flash an ESP-WROOM-02U. First, you can see I have the Arduino ground connected to what I will call the negative column on the breadboard. And I have the Arduino Due 3.3 volt supply connected to the plus column. And I have a jumper connecting 3.3 volts to the right plus column too. Note here I have a jumper connecting the Arduino reset line to ground. This is really important because it puts the Arduino in a state that allows it to be used as a basic serial interface. In the reset state, basically we just have a straight communication channel between the USB connector and the serial lines TXO and RXO. Speaking of the serial lines, this is how we will connect them. TXO on the Arduino gets connected to TX on the Wi-Fi module, and RXO gets connected to RX. Now, you may be saying, what? That can't be right. I always connect TX to RX and vice versa. But I insist, for the purpose of flashing the Wi-Fi module with an Arduino, what I show here is correct. TXO is connected to TX and RXO is connected to RX. This is not a mistake. Okay, Moving on to the wiring of the Wi-Fi module. We connect VCC to the 3.3 volt supply line. Again, this is only feasible with a Due, which can provide sufficient current to run the ESP module. Ground gets connected to ground, of course. Next, we will connect 4 10K ohm bootstrap resistors. And yes, you have to use resistors. Simple jumpers will not work. I am using 10,000 ohm resistors because that is what is recommended in the documentation that I could find. Other resistor values might work, but I don't know where the limits are. Just use 10K resistors and you should be fine. So we put one bootstrap resistor from EN, enable, to high, which is 3.3 volts. We connect GPIO 15 to ground with a resistor, and we connect GPIO 2 to 3.3 volts with a resistor. And we connect reset to 3.3 volts with a resistor. For flashing, we connect GPIO 0 to ground with a jumper. The Arduino Due has 2 USB connectors. For this operation, with the Arduino Due in the reset state, the USB cable must be connected to the programming port, which is the one closest to the power supply input connector. Okay, so here I have my Arduino Due and Wi-Fi module all wired up exactly as shown in the previous diagram. I have the flasher with the bin file ready to go. I'll plug in the USB cable to connect the Arduino to my computer. The device manager shows the Arduino is connected to COM4. By the way, make sure you don't have the Arduino IDE serial monitor open because it could conflict with the flasher. Just close the IDE if it is open. So now I go to the flasher, put in the correct COM port, the bin file is selected. Now I click download. Aha! Failed to connect. This means there's a problem. Basically, the flasher is saying the communication with the Wi-Fi module is not working for some reason. I created this fault on purpose because with my previous videos, many viewers encountered this problem. In many cases, viewers saw this error because they were not using a good 3.3 volt supply to power the ESP module. Here we are using the Due's 3.3 volt supply, which is fine. But it is a little surprising what some viewers have tried to use as a 3.3 volt supply. Don't mess around. If you don't have a Due, buy an external 3.3 volt supply to run your ESP devices. Another reason people get this error is because they neglect to connect the ground of all their devices together, and they end up with a voltage step between the serial devices. Here we are fine. The ground of the Arduino and the Wi-Fi module are connected. Another thing, this ESP error is often due to simple wiring mistakes, like this. I connected GPIO 2 to ground, but it should be connected to 3.3 volts. Please don't ask for help in the comment section of this video until you have checked your wiring 3 or 4 times. It is so easy to make little mistakes like this. So I will fix my mistake. Cycle the power to the Wi-Fi module. And now clicking download should work. This looks normal. You should get to 99%, then you will see this message, failed to leave flash mode. That is normal. So, we are done with flashing. Hooray! Sorry it took 19 minutes to get to this point. Now I will wire up the circuit that I demonstrated at the start of this video. You can see here that I have added the LED and potentiometer to the breadboard. Also, I have connected the external antenna to the ESP-WROOM-02U. Here is the wiring. First note, I have removed the jumper that connected reset to ground. With the jumper removed, the Arduino will be able to run a sketch and handle all the inputs and outputs. Next, make sure you remove the jumper that connected GPIO 0 to ground. You can leave GPIO 0 floating. This will cause the Wi-Fi module to act on instructions from the Arduino according to the AT commands firmware that you just flashed onto the Wi-Fi module. Now, note the new positions of the serial lines. We are no longer connected to RXO and TXO. Do not try to run a Wi-Fi module with the Arduino TXO and RXO lines because chances are you will have a conflict with your debugger. A lot of viewers have made that mistake and it causes the circuit to fail. As shown here, I have the Arduino RX1 connected to the TX pin of the Wi-Fi module, and I have the Arduino TX1 connected to the RX pin of the Wi-Fi module. I know, this is different from the connections we made when flashing. When we are running in what I guess you would call the normal state of operation, we have RX connected to TX and TX connected to RX. This is not a mistake, and I know it is a bit confusing because it is opposite of the configuration for flashing. As I said before, we will leave GPIO 0 floating, but all the other connections on the ESP module remain the same. VCC is connected to 3.3 volts. Enable gets connected to 3.3 volts through a bootstrap. GPIO 15 gets a bootstrap resistor to ground. GPIO 2 gets a bootstrap resistor to 3.3 volts. Ground is connected to ground, and reset gets a bootstrap resistor to 3.3 volts. In my circuit, I use digital pin 42 to drive the LED. The cathode of the LED is connected to ground, and the anode is connected to a 100 ohm resistor. And I have the other end of the resistor wired to pin 42. This is a 10K potentiometer. I have one fixed point connected to ground, and the other fixed point is connected to 3.3 volts. The wiper of the pot I have connected to analog 0 on the Arduino Due. And of course we connect the Arduino Due 3.3 volt supply to the plus rail on the breadboard, and we connect ground to the minus rail. And that is our circuit, all ready to go. Next, you should get the latest version of Blynk on your phone. You can get iOS and Android versions in the App Store. So, after you get the Blynk app loaded onto your phone, open it up, you'll have to register and then log in, and then you'll have this screen. And you start by pressing on this button, New Project. We'll give it a project name. We'll call it Due LED POT. And the device we're using is a Arduino Due, right there. And the connection type is Wi-Fi. So now we just create project. And Blynk will send an email to your email address. It will show the authentication token that is assigned to this project. We'll look at that email in a little while. Click OK. First thing we'll do is we'll add a value display. Open up the properties. We'll call this display millis. And the pin is a virtual pin 5. That will make a little more sense after we write the Arduino sketch. But just for now, virtual pin 5 is our millis. Okay. Now we will add a button. Go to the properties of the button. And this button will be called LED. And just for fun, we'll make it a red color button. And as I mentioned earlier, the button or the LED will be controlled on digital pin 42. Here we go. And these buttons, at least for this type of circuit, they make more sense when you make it a switch type button. Say OK. And finally, we will add a gauge. And the gauge, a couple properties. The value 1023 is, by coincidence, the perfect number. We're going to be measuring the analog to digital input on the Due, and that A to D converter has a range from 0 to 123 bits. So that's perfect. We'll call this gauge potentiometer. And the pin, as you may recall, is A0, analog 0 on the Due is monitoring the wiper of our potentiometer. Say OK, and OK. So now our Blynk app is ready to receive data. And all we have to do is set up the Arduino sketch in order to interact with this. Next, we will have to get the Arduino IDE configured in order to use an Arduino Due and Blynk. Under Tools, Boards, you will need to have the Arduino Due available. If you've never used an Arduino Due, then it's quite likely that you don't see this in your list of boards. So in order to get the Arduino Due listed in your board manager, go to Boards Manager, type in SAM as your search criteria, and you should see this, this package available, which is for the Arduino Due. Click on it and install. I've already installed it, so I don't need to do that, but install that, and then you should be able to see under Boards your Arduino Due, and you select Arduino Due programming port. Next thing you need to do is to make sure that you have libraries available for the Blynk app. Here I have my Blynk libraries listed, so I know that they're installed properly. If you've never used Blynk before, then there's a good chance that you don't have those installed in your IDE. So go to the Blynk website, getting started, and then they have a set of instructions that explain how to install the Blynk library. Just click on this, follow the instructions, and you should be good to go. All you have to do is check again, make sure you have these two Blynk libraries available in the IDE. Okay, after you confirm that the Due board and Blynk libraries are installed in the Arduino IDE, it is time to write the sketch. Fortunately, Blynk makes it pretty easy. They provide a sketch builder in their website. So you come down here, sketch builder. And we will use this sketch builder to write most of our sketch. So the board that we're using is an Arduino Due. Select Due. The connection is an ESP8266 Wi-Fi shield. Authentication token. Now this is where we use the email that was sent to us by the Blynk app. You may recall a few minutes ago when I created the Blynk app, the app said that it was sending an email to me. Here is that email, and here's the authentication code for my Due LED pot project. So copy the authentication code. It's 32 characters. And plop it down in here. And then for the example, click Push Data. Now 95% of the code is written for us for our Arduino IDE sketch. So copy the example. By the way, if this sketch builder doesn't work in your browser, try a different browser. Sometimes it doesn't work in Internet Explorer, but it does work in Chrome or Firefox. I'm using Firefox. So go to the Arduino IDE and paste the code that you copied from the sketch builder. There are a couple things that you need to change. you'll need to enter your network name and your network password here. So this is this default setting is correct. The Arduino talks to the ESP module at 115200 baud. That's good. Now you remember when I set up the Blynk app, I chose virtual pin 5 to handle the millis input. This is the part of the code where we're telling the Arduino that there is a virtual pin number 5, and that is where you send the millis information. Debug console. So almost everybody uses the debug console when they're running Arduino apps. I run my debug at 115200. So you might want to change that if you also want to run your debug console at 115200. Pretty much that's all you need to do in this sketch in order to have it ready for programming. So now I've got my network information written into the code. By the way, I'll have this code saved and available in the comment section of this video later. So the next thing I'm going to do is connect the USB cable to the programming port on the Due. And then click compile just to make sure things are working okay. And then download. Done uploading. Let's take a look at this. Open our serial monitor. Connecting to my Wi-Fi. It's made connection with the ESP module. It's connected to my Wi-Fi. Ping. That's what we're looking for. All right. The circuit is working. The Wi-Fi is working. Blynk is working. I'll get my phone out and we can play with this circuit. Okay, so I'll plug in the USB cable and I will press the play button on the Blynk app. It says the app is offline. Let's open up the serial monitor. Don't worry about this. Sometimes it says failed to enable mux. It's never caused a problem for me before. Here we are connecting to the Wi-Fi, and right after you see the ping, you should see this millis start to update. There it goes. So now millis is updating. That's the time that the board has been running the sketch. We can turn the LED on and off, and turn the potentiometer, and the gauge tracks the position of the potentiometer. So great. Our Blynk app and our circuit is working. The ESP-WROOM-02U is talking to the Wi-Fi on this external antenna. So we're looking good. So a lot of people build the circuit and write the sketch as shown in my videos. But then the Blynk startup process fails. Basically, they do not get to the point where they see this ping in the serial monitor. I will go through some of the common problems that are seen and where to look for setup problems. Sometimes you will see this message: ESP is not responding. This means the Arduino is working, but for some reason the Wi-Fi module will not respond correctly. I would say there are 5 common reasons that people see this message. The first common reason for this error is an incorrect version or non-existent AT commands firmware on the Wi-Fi module. Yes, when you get a Wi-Fi module, it will probably have some version of ATCommands firmware installed on it, but you don't know which version. And as I showed before, Blynk has a preference for a certain subset of versions of ATCommands. So you really should go through the process of flashing your Wi-Fi module regardless of what condition you think it's in. So flash the Wi-Fi module and get the correct version of ATCommands onto the Wi-Fi module. The second problem I often see is people forget to remove the jumper connecting GPIO 0 to ground because they flash the module and then they jump right into building the rest of the circuit in the programming, and they just neglect to remove that jumper to ground. So make sure your GPIO 0 is floating or connected to 3.3 volts. The third common problem I encounter is people do not connect the ground of the Arduino to the ground of the power supply and the ground of the Wi-Fi module. So in this case, you can see I have the ground of the Wi-Fi module connected to the ground of the Arduino. That's all we need. But if you don't have that ground, then you will have a voltage step and communication will probably not work. So make sure your grounds are connected. The next common cause for getting the ESP is not responding is that the user has used TXO and RXO on the Arduino board as the serial interface with the Wi-Fi module. Don't do that. It just won't work with this simple sketch and the hardware that we're using. I showed in the video how to use RX1 and TX1 on the Due. It would be a similar setup with a Mega. And with the Uno, you can use a software serial connection with the Wi-Fi module, which I showed how to do in another video. The other common cause for seeing ESP is not responding is an underpowered or unstable 3.3 volt power supply for the Wi-Fi module. Now, in this video, we are using the 3.3 volt supply from the Due, which is fine. But lots of people want to use the 3.3 volt supply from a Mega or Uno or some other device that cannot provide the 430 milliamps that ESP modules need. Actually, I suggest using a 3.3 volt supply that is capable of 1 amp. Benchtop supplies are good, or you can get a power supply like this. So the next type of error that people see when Blynk tries to run is this: failed to connect to Wi-Fi. When you see this information in the serial monitor, you can be confident that communication between the Arduino and the Wi-Fi module is working fine. But the Wi-Fi module is saying, yes, I'm alive, but I cannot connect to the Wi-Fi network that is specified in the Arduino sketch. There are two typical causes for this problem. One, the Wi-Fi details were not entered correctly in the sketch. Double-check the SSID and password. The other reason you could get this message is if there is a bad connection between the Wi-Fi module and the external antenna. If your Wi-Fi module has an onboard antenna, then you probably don't have to worry about this. Another reason you could get this message is if the Wi-Fi signal is too weak and the Wi-Fi module simply cannot see the network. There's another problem that can occur when you're connecting. You may see connected to Wi-Fi, but you never get the ping. The system just seems to sit there. Typically, this means your Wi-Fi connection is good, but there is something preventing communication with the Blynk cloud. First, you should try cycling the power to see if some glitch occurred during startup. But if you never get this ping message, then most likely you have a network issue. Perhaps you don't actually have internet access, or perhaps your network has a firewall in place that is preventing communication with the Blynk cloud. I have a secure network in my office with a firewall, and it does not let my Wi-Fi devices communicate with Blynk. So, when you have a Wi-Fi connection but cannot get a ping, the best thing to do is to try a different Wi-Fi network. For example, I've used the Wi-Fi hotspot on my phone to connect to Blynk. An alternative is to use a local server, which just so happens to be the next topic of this video. Up until this point in this video, we have been using the Blynk server to handle the data exchange between our devices. Using the Blynk server is convenient and easy to use, but you can also set up a local server to handle your Blynk data. A server is, quite simply, just a computer on a network that runs special software. Now, in the high-tech business world, servers are often comprised of specialized equipment, and they are usually connected to the internet in some way. But a server does not have to be connected to the internet. And a server does not have to be some special high-tech computer. You can use almost any computer to be a server, even your average desktop or laptop. So that is what I'm going to show how to do. There are three main reasons you might want to run Blynk on a local server. First, you might be in a place where internet access is unreliable, so running your project on a local server eliminates that problem. However, it should be obvious that in this situation, your project will only work within range of your Wi-Fi or local network. Second, a local server provides a great deal of data security because you set it up and you control the access. Third, in general, you can probably get faster and more stable communication between your devices if you use a local server. So I am going to install and run the server on my laptop at home. There is nothing special about this laptop. It's running Windows 10, and my Wi-Fi network is a pretty standard home network. It was set up by AT&T, which is my internet service provider. Now, I'm going to show just the very basic steps needed to get a Blynk project communicating with a remote device on Wi-Fi using a local server, like what I show here. I won't be covering all the network variations and enhancements, like port forwarding, that some users might be interested in. Sorry, there's only so much one can pack into a tutorial like this. So let's get started. You need to have Java JDK installed on your machine. So first, check to see if maybe you already have it installed. To do this, open a command prompt window and type java-version. If you have Java installed on your machine, you will see something like this. I think the minimum Java version needed to run the Blynk server is Java version 9. But you can see on this particular machine, I'm running Java version 10.0.1. If you do not have Java JDK installed, and you type in java-version, you will see this. Java is not recognized. So, no problem. You can install Java. At this point in the video, I was going to walk through the steps showing how to install Java JDK, but I realized there were already YouTube videos showing how to do it. I highly recommend this one by Programming Knowledge. It's a pretty recent video, and I really cannot explain or show the installation process any better. So if you need help installing Java, follow those instructions. Then come back to this video, where we will continue with the installation of the Blynk server. Okay, so I have just installed Java on this machine, and you can see it is running Java 10.0.2. Once you have Java JDK installed, the next thing to do is to go to GitHub and look for Blynk-server. Scroll down a little ways until you see Download Latest Server Build here. Click on the link. Ignore the one for Java 8 and download the server.jar file. Today we are at version 0.39.4, so this is the file we want. So click here to download, click Save, not Open, and a good place to put the server file is in the User Documents folder, like I have here. So now we have the server file saved in the Documents folder. Click in the field for the file path, Control-C to copy the file path, or just remember it. We will need this file path in a minute. Open a command prompt window and change directory by typing cd and then put the file path that you just copied. Confirm you are in the Documents folder, then type java-jar, then the server file name, -data folder, server_data, and the and symbol. This command is saying that we want to run the server, and we want to create a data folder called server data, and all of the data is going to go into that folder. The and symbol just means that we're going to run this in the background. Hit return, and the server should start up. And you should see a bunch of information like this. It is important to see server successfully started. And notice in the Documents folder, you will now have a folder called Server Data and another folder called Logs. Now, it is important to remember that this computer has to continue running and the command prompt window has to stay open for the server to run. If you close the window, or if your computer goes to sleep, then obviously the server will shut down. You'll have to restart the server to get the Blynk connections working again. Next, we need to determine the IP address of the machine that is running the server. To do this, go to the command prompt window and type ipconfig. A bunch of info will be spit out, but this is what you are looking for. Later, we will enter this IP address into Blynk and the Arduino sketch, so that your phone and the Arduino both know where the server is running. Now, at this point, your server is ready to connect devices that are all on the same network. There are some more things that one might want to do with the server, like setting up mail properties, site certificates, and so on. I think those are advanced topics that are beyond the scope of this video, but I do like this video by Sid's eClassroom. He covers a lot of advanced topics on the Blynk server, so check it out if you're interested in those things. Next, we will set up Blynk so that you can run projects on the local server that you just set up. I will show how to connect Blynk to the same Arduino Due circuit that was used in the first half of this video, but instead of using the Blynk server, I will be using the local server. So make sure your phone is connected to the same network as your server. Open Blynk. If you are currently logged in, then log out. Click Create New Account. Click this icon. Move the slider to Custom. Enter the IP address that we got from the command prompt a minute ago. For me, it is 192.168.1.240. For you, the IP address will be something else. In this box for the port, type 9443. Click OK. In this window, you will enter an email and password, but with the current state of our server, it doesn't really matter what you enter here because we don't have access to an email server. So you can type anything here as long as it looks like a real email address. Same for the password. Type anything. Here I will type 123. Just make sure you remember what you type. Click Create New Account. And you should see the familiar Blynk project interface like this. If there are problems, you might see this message: Can't connect to host. If you see this message, check these things. Make sure that both your phone and the server machine are on the same network. Make sure your server is running. If your computer got turned off or went to sleep or something like that, then your server will get shut down. It's no big deal, just restart the server. Another thing to check is to make sure you entered the correct IP address for your server. You have to get it from a command prompt window like this. Make sure the IP address gets entered correctly and the port is 9443. Once you have connection to the server, you will be able to create a new project. So let's start a project and call it Due LED Server. Just like before, we select the board that we are using. In my case, it is an Arduino Due. The connection type is Wi-Fi. Tap Create Project. So here, Blynk is going to say that it has sent an Auth Token to your email address. But as I said, we aren't connected to an email server, so don't expect to receive anything. Later, we will get the Auth Token into our Arduino sketch using a different method. Click OK. Now we can add our widgets. The setup is exactly the same as what I did earlier in the video, at about 24 minutes. I'll fast forward through it this time. We are going to need the Auth token for this project. We will put it into the Arduino sketch so that our devices can talk to each other. To get the Auth token, tap this icon in the upper right corner, and you will see the Auth token here. You might want to write it down, but I think it is easier to press and hold for a second or so. This will copy the Auth token into your clipboard. Then you can paste the Auth token in an email and send it to yourself. Okay, so what I have here is the same setup that we had earlier in the video. Right now my phone is connected to the Blynk server, not the local server, and we're running the exact same sketch that was entered earlier in the video. The LED works and the potentiometer works. Now we're going to switch to the local server and run the circuit in exactly the same manner. So the first thing I'll do is log out of the Blynk server, and I will log in to our custom server. This information is still the same, the IP address and 9443. Okay, I have to change back to my fake email address. Okay, so I've logged into the server. This is the project that we just created. So next we're going to update the Arduino sketch in order to connect to the local server. The first thing we're going to do is change the Auth token that was created on our new project. I sent that to myself in an email a minute ago. Here it is. So I go into the sketch, change the Auth token. The next thing we're going to do is tell the Arduino sketch that we're not going to talk to the Blynk cloud. We're going to talk to our local server. And that's what I'm telling it here. This is the IP address of my local server. 192.168.1.240. So now we're ready to upload to uploading. Let's look at our serial monitor. ESP is not responding. We got our ping. I don't know why it said that the ESP was not responding. Hit play. Millis is updating. And the light turns on and off. And the gauge still tracks the potentiometer. So now we have the system working on a local server, not the Blynk server. Woohoo! So I packed a lot into this video. I explained some of the benefits of using the Arduino Due. I explained a little bit about the ESP-WROOM-02U, and I showed how to set up a local server. Hopefully you were able to get through this nearly hour-long video. I'll put as many links as possible into the description, and I'll give the Arduino sketch as well. Have fun!